Just give me a few minutes. I'm setting up my mobile. Hello, students. Good morning. Sorry for being late. My computer has decided to lock itself by using BitLocker, and I don't know why that happened, but I have corrected the problem. Hopefully, it will not happen again. Good morning, Ravindra. Okay, just give me a few minutes. Let me open up my notes. Today's lecture, I want to keep it very hands-on. I don't want to spend much time on theory. Like I'll spend some time on theory, but a lot of time will be hands-on coding. Good morning. Good morning, Vivek. Let me see encryption. Decryption is going on. So let's start with the concept of indexes, shall we? So what is an index? Have you ever seen an index at the back of a book? So what happens is there's a book and there's a lot of content inside the book. And at the back of the content, at the back of the book, there is an index where it is written a given topic. For example, Mongo DB, suppose Mongo DB, Mongo DB ID. Suppose this is written, and in front of it, the page number will be written. Suppose 37 is written. Then as at page number 37, you can find details about MongoDB underscore ID. Okay, this is called as index. Now, you can flip through any technical book and you will find at least one index at the back of it. It is very similar to table of content, but table of content is topic wise, whereas index is concept wise. So there is this concept of index. Now let's look at how you would have implemented MongoDB if it was your task to implement it. Imagine you will have a very big array where each index in array corresponds to an ID. So an object ID. So ID say 1 or 0 will correspond to the first position in the array. Then ID 2, ID 1 will correspond to the second ID in the array, and so on and so forth. Actually, it does not happen like this. It happens in hard disk, but I'm not going to discuss hard disk and all those details. You can very well imagine you have a long array where every ID is mapped to each one of the indexes of the array, and all the documents are saved in this array. This array is for one collection. Okay, every collection will have a similar array, and documents for each of the object ID will be saved at each of the indexes. Okay, Nitish, do you follow this diagram where I'm creating an array with documents? And this array is created. If I give you the ID, you can get the document in O of 1. Why? Because you can just look up the index in the array and get index of that ID in the array and get that object or get that document. So if somebody says, give me the document where the ID is equal to 87, you will just go to index number 87 and get the document. Does that make sense? Yes or no? So it is very easy to retrieve documents if you have index given to you. But index is something you don't search usually. You don't usually search your documents based on indexes. If you have names of all the students in this class, you will not remember what is the ID of Archit. What you will want to do is you want to do some query which looks like this: db dot user dot find, and what do you want to find? Name, where name is equal to Archit. This is more usually the way you want to do it. Okay. Now the question arises: how will you create? What will you change? So how will you get this? First of all, if you have to do it brute force manner in the array, there are a bunch of documents saved in the array, and you have to get a document whose in which the name is equal to Archit. You'll have to iterate over every document, and until you find Archit in a document, you cannot do anything. You have to go through each of the document and see if Archit is written as the name. Does that make sense? To to do away, Vivek, does that make sense? Does this operation make sense to you? This will be O of n. This is array of documents. This is, yeah, this is an array of documents. Exactly, Karan. This is an array of documents, and what you are doing is you are finding a document in which the name is Archit. Vivek, does that make sense? Is your internet correct, or is your connection good today, or it is causing the same problem today as well? Hello, Vivek, are you in the class? Uh, Let me see if he is in the class. I saw his name, therefore I was asking. Uh, Maybe, yeah, he is there. Hello, Vivek. He is fixing the issue, same problem. Okay. Uh, okay. Maybe you can talk to the operations team once, Vivek. After today's class or during today's class, you can just contact the operation team and get it fixed, because I think this is causing some problem in your learning. So make sure you. Yes, Mongo DB internally uses. There's no other way. Searching name in array should take O of n. Yes, this will take O of n time. It will take a linear search query. It does a little different. It has some hardware optimization, but basically it is a linear search query. So what you have is bunch of disks which are in your hard disk, or if it is doing it in SSD, there is a different method. But the idea is you just go through each of the documents and then find a document in which the name is Archit. We but we won't be bet we want better than linear. Yes, we want better than linear search. When is it O of n? O of 1? If I do something like this: db dot users dot find, and give me, say, underscore id as 8. Suppose this is what I sent. Actually, it should be object id 8, object id 8. But if I send this will be O of 1, because IDs are indexed. So based on the ID, it knows where this document is saved exactly, so it can directly go to that document. Okay, yeah, that's how it works. So what is an index? Now I can create an index on name. So what I can do is I can have another index which is just a mapping from a name to the ID. Because if I have ID, I can get the answer very quickly. So if I save at one place, what is the index for Archit? Say index ID for Archit is 23, then I can directly go to the document number 23 and get the document. I just need a place where this is saved. Does that make sense? Ravinder? Okay. So we can create an index based on our DB. Exactly. That's what we need to do. You just create an index which says, uh, we can just do create. There's a command called create index, and we can say that I want an index based on name, and it is a text index. So I'll just do name text, and this will create an index on name, and you can just search on the name. This is what there is. Index per collection, right? You can have multiple indexes. Nobody is stopping you from having multiple indexes, Archit. Because if you can remember that Archit is document number 23, you can as well remember that single is document 23. Okay. Index me. Okay, I'm going to explain that in few seconds. So it's okay to just have single as well. Single as 23. Now you have two indexes, index number one, which is from name, index number two, which is from the surname. Okay. Is this process same as normalize? No, this is not same as normalization. Don't confuse it. What if we have duplicate collection? What does that? No, no. If you are creating an index on a term, it should be unique. So you cannot create an index on something which is not unique across documents. That will not work out. Okay, got it? Yeah. Index, if you create an index on something, it has to be unique. There cannot be two Archits in the class if you want to create a index on Archit. Yeah, I'm just giving you an example here, Gauri. You cannot have two Archits if you are trying to create an index. It has to be unique. Okay. Or if you are not sure that Archit is not going to be unique, then what you need to do is you need to combine it with single. So it should be a combination name and surname. Okay. And you say that name surname is unique. If name surname is not unique, you can have name surname and ID. Yeah, yeah, there can be a case where they are not similar. I mean, that when there are copies, but typically what you want to, I mean, it will not run if there's a copy present. Okay, so you have to be clear on it. One document can have multiple fields as index. Now I'm going to come back to doubt of Vivek, but I will first ask him how is his connection right now. Vivek, how is your connection right now? Is it good? I think he raised his hand. How is your connection, Vivek? Hello, Vivek. I think he is not connected. Okay. No worries. I I I hate it when the internet is when when the computer gives up. Today last night my computer gave up. It just bit locked my system. There's something called as BitLocker in Windows, and if it is enabled, you have to write. Yeah, it is similar to array indexes. Like one, array can have we may multi. Yeah, that is true, Navneet. That is exactly true. Today my computer got bit locked and I was worried about how I will take the class, but suddenly it was opened and I was happy. Okay, so anyways, this is not relevant. But anyways, array can have multiple indexes and you can query from each one of them. Okay, now I want to talk about how an index in a database works. Okay, you typically don't use the hash map for indexes, although hash map can be a good choice, but um, since they sometimes want some kind of ordering also in the index, the usual idea is to have a B tree. Okay, not binary tree. This is B tree. There is a different kind of tree called as B tree, um, and I'll give you a visualization of B tree. If you just give me 1 second. Hmm. Yeah, exactly. SQL B tree. Have you heard about that before? B trees. Okay. Then it will not take much time. I'll just revise it once. Hmm. Oh, my computer is. Come on. So many tabs got open. Hmm, hmm, hmm. Yeah. I don't know all about snow survey. I don't know. Okay, no worries. It's just a binary tree with some properties. I'll show you the demonstration. Nobody asked these trees in interviews, but they are very good if you want to do indexing. So for indexes, they are typically used. I'll just do B tree visualization, and if I go to CSUCF education, um, okay. So we have an empty tree. If I insert 4, it gets if I insert 5, okay, 5 comes here. And then if I insert 7, 7 comes here. So every node, root can at max have 2 children. Okay, and every node can have a sorted list. Okay, and I'll show you more. Let me insert more values. Let me increase the size first. Okay, so inserted 5, 7. Let's insert one more number, 6. Okay, so 6 comes here. It is stored here. And now if I insert say 8, so 8 comes here and it goes up. So this is a little complex. There are 3 children of the root node, and there are 3 children of the root node, and there are 2 nodes in the root node itself. There's 5 and 7. If you are searching for something which is greater than 5, you have to go to the left subtree. If you want to search for something which is between 5 and 7, you have to go to middle children. If you are searching for something which is towards the right, you have to go to which is greater than 7, you have to go to the right. Now don't worry about how things are inserted and deleted from this. All you need to do is search for something. So let me insert one more value, uh, 15. So it goes and adds to 15. Okay. Max degree is 3. So every node can have at max 3 children. Okay. Now, if there are more than 3 children, we split the node. For example, if I insert 9, 9 comes here and we split since it had 4 children, root node had 4 children, I split it into 2 subtrees. And this way the tree keeps on growing. And one thing you would have noticed by now is that this tree is always balanced. This tree is never unbalanced. So if I insert say 2, it will come and sit at 4. And if I insert, say, no, 3, now this will split 5 into 2 children, and suddenly there are 2 children in 5, and so on and so forth. Okay, I know this does not make sense, but this is how you can store values. And for each of these node, we will have a pair. One is the field on which we have created the index, and the other will be the ID of that node. Okay, so this is a tree. You can think of it as a simple binary search tree, and it is going to save your index. Any questions about B tree? I know I'm not going into the depth, but that is not required for this topic. Okay, no questions. What? Where it stores the field? It stores the field. So this 9735 are actually going to be the field itself, the value of the field, and there will be a pair which will be stored. There will be the field, the value of the field as well as the index, just like I have shown in the diagram. There will be a pair. One is the field and the other is the index ID. The other is the ID. So that's how you can do by B trees in maps, uh, B trees in indexes. Now let's do some hands-on processes. So where is it using hash map? It does not use hash map. It uses B tree. I showed hash map because it was easier to explain with hash map. It was easy to explain the indexes using hash map. It actually uses B tree at the back end. But for all intents and purposes, you can think of it as a hash map. There's no need to think of a B tree. Yeah, now I'm going to open my compass, Mongo DB compass, and we'll create a table, which is a very big table. Mhm. Okay. Let me ask, who was the person last? Was it Likhit or was it Navneet? Navneet, are you there in the class? Are you able to connect to connect to MongoDB now? Has the problem resolved? I think there was a problem yesterday that you are facing. Okay, you connected. Okay, no worries. Anyways, okay, no worries. I'm going to create a new database and let me call it Twitter database. So I'll just come to Mongoose and I'll do uh, what was the command for creating a database? Uh, Database dot create. No, db dot create collection. Mm, Show dbs. These are the dbs. Use. I remember. You can use Twitter. That would be the way. Yeah. Now you have switched to Twitter. Let me increase the size of this. Okay. So now I'm going to insert some values into my Twitter database. For that, I'm going to use a for loop. So for I is equal to 0, I less than 1 million plus plus I. Sir, we need to install Mongoose. Yes, you need to install Mongoose, Navneet. Is that Mongoose working on it? So, Navneet, one problem that you are facing right now is uh, probably that you are using Mongo DB of version 3.0, whereas the latest version is 6.0. So that is one problem that I see in your setup. Maybe you can fix that, and then you can install Mongoose Shell, and it will work out well. Yeah. So we have index from y is from 1 to million, and then what I can do is I click on tab. That works. I need actually I'm not going to worry about this one. uh, Actually I'm going to write the code in VS Code and then paste it. So I'll just stop sharing this. I'll share the whole screen because I don't want to switch again and again between my screens. And I will come to VS Code before writing it down to Mongoose. So first we'll create a database. First we'll create a big collection so that we can check what is the in one or two values. It's very difficult to see the difference in performance. But if you have a million values, it's easy to see indexes in Mongo DB, and this is from 17th of December 2022. And in this, I'm going to create a new file. I'll call it indexes.md. And the first thing is create a collection. So uh, let's create a collection with 1 million. I'll just write at 1 million documents. We put the user input logic inside the for loop? Yes, we can. I'm going to show exactly that now, Abhijit. Okay. Let's create a collection with 1 million documents. So for this, what we are going to do is for I is equal to 0, I less than 1 million. This is 1 million plus plus I. I don't like this. You come here and write var user. User is a object which has user ID, which is probably I. There is username. In this case, I'm just going to call it user plus underscore whatever is the index. That is the username. Age. I'm going to calculate age by math.floor, math.random times 100. Somewhere between 0 and 100, the age will come. Once I have the age, I'll save some more things. Created at new, some random date will come. Modified at another date will come. new date, and then count of this is Twitter, so there will be followers or friends. This is also math.float. Yes, Vivek, we are going to write this code on uh, on Mongo DB terminal. Mongoose, we are going to write this code. Is your computer working well now, Vivek? Hello. Count of friends. What we are doing? We are creating a collection with 1 million users, so that I can teach you the impact of creating indexes. Okay, Vivek? And to create this collection, no, I join on mobile. Okay. Okay. So I'm creating uh no, I don't think you need a lati, but if you are saying, I'll just write it as lati. Let me write it as lati. That should be okay. And then number of posts is math.float. There are some number of this is the user object that I'm creating. Okay, this is a random user that I'm creating, and I'm going to create 1 million of those random times 2000, and that's the user. The next step would be to just do db.users dot insert one, and you can insert the user. So if I paste this code into Mongoose, I'll have 1 million users my uh, inserted into my user table. So I just have to go to Mongoose, and I'll come here and I'll do Control V. DB Twitter. Yeah, DB Twitter you don't have to write. Uh, no. Twitter is the database and users is the collection. So when you are in when you are in DB Twitter, you don't have to write it. Why is this? Yeah, I want to scroll up. Yeah, this is fine. This is fine, and this is fine. I can just come here and click enter, and this will take some time. After some time, it will insert the million rows. Line 7 explain. I'm going to open the VS Code. Line 7 says username is a combination of user and I, which is index. So every username will be user 0, user 1, user 2, so on and so forth. It will be like uh, user underscore 0. This is underscore 0. This will be the first user. Then user underscore 1, and so on and so forth. Okay, Vivek, do you see what is happening here? This code you can write inside Mongoose. You can have a for loop inside Mongoose, and I'm creating a user object. Okay, Vivek, does that make sense? Now this user object is a random object that I'm creating. I'm giving it a random age. I'm giving it a random number of friends, a random number of posts, and a date on which it is created, a date on which it is modified, an age, and a username. Does that make sense, Vivek? Now I'm going to add all these users, 1 million users, into my Twitter database in the users collection. And I'm going to search for a given user based on his user ID or based on his username, and I'll show you line 11 and 12. 11 and 12 is just math.floor, math.random. You know math.random function in JavaScript, how you can create random numbers between 0 and 1. So if you multiply it by 500, you will get a number between 0 and 500. Okay, and a number between 0 and 2000. That's what this math.random is doing. So you are randomly giving a value for each of the user. Any other line that you want help with, Vivek? How much time it takes? I think it would have worked till now. I'm guessing that it has completed. No, it is still running. It will write the values. Why do we need line 12? Let me check what line number 12. It's just a random field that we want to add, Vivek. It's just a field that we are adding. Hmm. Let's see how much time it will take. This should give us some kind of uh, intimation that it is running. So it will take some time. Shouldn't all properties of user be string? No, it's not. It sometimes date has to be date and count of friend should be integer and so on and so forth. Username, it's okay. You can add a number into a string. No, Bison type can be anything. Bison type are strings. There are multiple Bison types. Strings, numbers, object ID, all of them are Bison types. Yeah, only string is not there. Props, not values. No, no. Props. That's okay. You can properties. You can save as this one, Avijit. It's okay. In MongoDB, you can have variables as properties. That's okay. When developing the backend, we don't need to run these queries into Mongo DB shell as we create the schema using Mongoose. Yeah, that is correct, Ankit. But sometimes what happens is you don't want to write all the backend. I mean, sometimes when you have to test or debug your code, you have to do these queries so that you can look at the production database or dev database. Okay, Ankit. So sometimes you have to look at the database also. So you need to know these queries. I don't know where it is showing the count. It should be showing the count somewhere. Refresh, sir. Okay, let me refresh. Uh, if I just click here. Oh, that way. Oh, got it. So I'll just do this. I'll click here. I'll refresh. And there's a Twitter data set. And there's this 69K have been inserted. Okay. Uh, let's see how many we can insert. 72. It's very 72K. So it will take a lot. That is true. It will take some time. Yeah. It will take around 5-10 minutes to insert all the values. Um, let's wait for that. Yes, Vivek. Vivek, if you have any questions, this is the best time to ask. If you want to unmute yourself, till uh, I should have inserted 100,000 actually. Explain index. Okay, I'm going to explain. Don't worry. I'm going to stop sharing and go back to the drawing board. Okay, so index is so Vivek, imagine you have an array which contains bunch of documents. Every element of the array is a document. Okay. Now every document will have a index 0, 1, 2, 3, 4. Okay. And if you want to access a particular document, if you know the index of that document, you can get it in O of 1 because this is an array. Does that make sense, Vivek? If I tell you that give me the object, give me the document at index number 23, you will directly jump to 23rd position and return it to me. So it will take O of 1 time. In MongoDB, every object ID is attached to the index. So MongoDB at the backend knows that if the object ID is 0, then the index is 0. If object ID is 1, so every object ID will be mapped to one index. Okay, there will be a map from object ID to index of the array. Does that make sense? So if you know the object ID, you can get the object. If you know the document ID, you can get the document in O of 1. Does that make sense, Vivek? Now, but what if somebody asks, you don't usually know the index of the element. You ask a question like, for example, if I say give me the object with give me the, so if I do something like db.user dot find, and I say that the ID of the user is object ID 23, then MongoDB can get it in O of one time because it knows the mapping from ID to the index on the array. Okay, so this is good. You can do it in O of one. But suppose I have the same array, but I ask the question, return me the document where the name is Archit. Now there's a problem. Unless you check all the documents for the name Archit, you cannot know where it is saved. Does that make sense, Vivek? So now this query suddenly takes O of n time, and we don't like O of n time. So to do away with this problem, we create an index which is nothing but a map from the field name to the ID 23. So whatever is the ID or whatever is the index of that document, we create a map from the field to that index. So now we know that Archit is saved at 23rd index. Just like you do in programming, you have a hash map where the field is the where the key is one value and the value is index in the array. So you do the same thing here, and suddenly you can do this kind of queries also in O of 1. You can just look up the index, find the index of, you can look up the map from name to index, and then you can find the index for the document which has the name as Archit, and to you can return that document in O of 1. Does that make sense, Vivek? This is what an index is. So one thing you might notice that if you have an index on something, that field has to be unique. You cannot have two Archits if you want to map Archit to a index in the array. So this is a requirement in MongoDB that index field should be unique. For all intents and purposes, this much knowledge is good. But one thing is there that, sir, but how Archit is 8 index? Uh, where is 8? No, it can be 8, it can be any value. It can be 8, it can be 23, it can be anything. The only thing is, you should know what is the index of a given document. What is the index of a given value for a field? If the value of name is 23, if the value of the name is Archit, what is the index at which this document is saved? If you know that, you are good to go. Now, one thing is there, these databases typically use a B tree at the back end to save the index. And I'll not explain B tree again because it's not that important. All you need to remember, it's a binary tree. So it's similar to a binary tree. It's similar to BSC, but it is a little advanced. How is it oven and repeat? Uh, when will we find Archit? When we will find Archit, then so many Archit is coming. Then that is not an index. Index, the key should be unique. Just like in maps, you remember, in map the key should be unique. If there are multiple Archits in the document, then you will do Archit single. You will look for the combination of name and surname. If that is also not there, you will look for the combination of name, surname, and date of birth, something like that. How is it O of 1 for Archit repeat, sir? So you have this mapping from Archits to the index of the document in the array. You can directly go to that index to get the document. Therefore, it is O of 1 because you know that access in a array is O of 1. If I want to access a particular document in an array, I can do it in O of 1. So if I know the index in the array, which I can get from this map, it will be O of 1. Does that make sense, Joseph? Joseph? Joseph Matthews. No, it's automatic. Everything is taken care by the backend. We have all the indexes. Yeah, that is true. Yeah, you don't need to know it. The database will know it itself. So the database will run through all the points and it will save the IDs. How do we insert the data in such criteria such name, age, another as it given already? Is it given already? No, when we insert, we have to remember that the value should be unique. Okay. So when we create our map, we have to make sure that value should be unique. You only need to do query, and you also need to write this function called as db.user.createIndex. Once you create the index, it will work out. Okay. Still, still at 140k data. Let me check how many data I have. Um, hmm. Let me refresh this. Mine is 204, so it will take a lot of time. Sir, couldn't we just terminate? I don't know. I don't want to terminate it. Let me do Control C. Let me see if that works. Uh, can we terminate it? Have I terminated it? Here, you click on database Twitter, look at the user collection, and then see yourself that the value is there. I cannot terminate it right now. Control C or Control X is not. Oh yeah, it worked. So now if I refresh this, yeah, let me refresh it. Sir, automatically only apply to docs and collections too. It will apply to docs. So we have inserted 218k documents, which is good. Now I can click on this and I can show you any individual document, how it looks. Let me do control minus here. So there are a bunch of documents. This is how a document look like. User number 0 has age 19 and these are the values. Okay. Now this is once it is inserted, there is a function that is there that I just want to talk about. It is called as explain. Explain is a function that gives you some data about uh, explain is a function that gives you some data about how the where does it show how much data. Okay, this I have answered. Yeah. So what is it called? Explain is a function that can tell you how much time a given query has taken. So I'll just do users dot find, and if I do user ID, if I'm looking for user ID, say 153 user ID, and I do explain, and I'm looking for execution stats. Let's look at the execution stats of this query. So it took some milliseconds. It will tell you how many milliseconds the query took. So these all are the execution stacks. And in this, there should be something called as false, collision, true, execution time, 272 millisecond. This query took 272 millisecond. But if I do, now this query will take 200. You see this You see this number, 272 millisecond. What does this 272 millisecond means? You know, this is the time it took MongoDB. Yeah, this is the time it took MongoDB to get the value of this data point. It got the value, and it took this query. Uh, it took this query 272 milliseconds to get it. It took to search for a specific user ID. Okay, Vivek, does this make sense? You are searching for a user ID 153, and this query actually took you 272 milliseconds. Hello, Vivek, are you connected? Explain. Okay, Karan. You see, I have a data set with a bunch of data. Okay. I have this document data set with a bunch of documents. All of these are documents. I have reduced the size for, yeah, purposefully. All these are documents in the data set. I want to search for a particular document for which the user ID is 153. And how I have created the user ID? I have created user ID by creating this like this. Every user has a user ID which is I, which is equal to whatever was the index at that point from 0 to 1 million. Does that make sense, Karan? Karan? Okay. So now once I run this query, it took me once I run this query, it actually took me 272 milliseconds. But now I'm going to do something with the data set. I'm actually going to create a index on user ID. I'll just do DB. Now remember, don't ask me what was the previous time taken. I'm going to do users dot create index, and in this index, I'm going to do user ID in increasing order. This says that if I just run this, it created an index on user ID 1. Now look at it, what happened. Let me reduce the size of this. If I click on this indexes here, first of all, let me refresh this. Let me refresh the localhost and look at the indexes and what it says. Let me refresh this. Create index user ID. There is this user ID. I want to see the other index. Let me refresh one more time. It is still being created, I guess. Uh, Give it few seconds. It will create the index. Refresh. Oh, I got it. You see what is the problem? I created it for capital U users. It should be small u users. Yeah, users. Now if I do no, just come here db dot users and click this. This will take some time to create the index. Now the index is created. Now we can look at here. If I refresh, there's an index which is 3.3 MB. There's an index called as 3.3 MB. And if I just open it, it is a user ID which is in increasing order. The user ID in increasing order is saved here. Now what I can do is I'll run the same query that I have run before, and I'm going to increase the font size now. I'm going to run the same query, which is this query, and let's see how much time this takes this time. This ran very quickly, and if I just scroll up, what is the execution time? Execution time is 0. Now it is 0 actually. It is less than 1 millisecond. Okay, this is the power of indexes. You see, Vivek, what is happening here? Karan, do you follow? Suddenly the time is reduced by a factor of 200. Karan, Gauri, do you see that? Do you see this magic? This is what is called as. Uh, and let's see how many keys were examined. So indexing sort the data, but it saves it sorts it and it saves it into a B tree. So you can access the data very quickly. Okay. So now there is also something called as uh, document accessed. There's something called as document examined. So execution stats. This is execution stat. No, this is execution stats. In this total document examined is 1. Only one document was examined here. Okay. Now let's look at the previous question. Previously, when we had this, total doc examined was 224 24 uh, 246,000. Okay, these many documents were examined previously. Now only one document was examined. If you examine one document, you have the answer that you are looking for. Does that make sense? Why pass 1 to create index? Because that shows that we want it in increasing order. If you want it in decreasing order, we can do it in the reverse also. We can do -1 also if you want the index in decreasing order. So that's the username. Okay. So now you can create indexes for anything. You can create an index for username if you want. You can create an index for other fields as well. Okay. How to check how much time index took? How much time the index took in creating? So you can do the same thing. Examine. You can write this examine in front of any query, and it will tell you how much time it took to create. Okay. So when you write examine in front of any query, it tells you how much time it took. Yeah. Now there can be for creating an index, is it required for the value for corresponding field to be unique? Let's check that. Let's check that. I think it's not required, but let's check. Let's create an index on age. For the whole document you can create, but that will cost. So let's do on age. No, just go here. Because age is particularly going to not be unique. So if I do age equal to 1, uh, yeah, it got created. Even if the value is not same, you can have an index. I was db.users.find, and let's look for age as 19. If I look for age as 19, it will return all the documents which have age as 19. Okay, and the index got created with 19 with age. So it need not be unique because it is saving it in sorted order. Okay, colleague. I think I said it has to be unique. I'm sorry for that. I was remembering something else, but yeah, it need not be unique. Then we can have find many query instead of find one. Yes, exactly. You can directly do find query on the database. Yeah. Yes, Vishal. Okay. So that's how you can create a index. Now we are going to take a short break. Once we come back from the break, we'll discuss some kind of compound indexes, text indexes. There's a lot of well, there's a lot of data in this class, but I think I can cover it in today's class. Text index is there, and there are range query types, and there are multi-key index, um, compound index, multi-key index. All these things are there. Okay, let's take a break for 18 minutes. Let's come back at 11:28, and then we'll continue again. Have your lunch, or maybe you will have it after the class. 11:30. Let's come back at 11:30 a.m. I'm going to mute myself. Hello students, welcome back to the class. I hope you are doing well. We'll just get started in a second. Make some noise if you are here. I would love if somebody writes Hakuma Natata in the chat when they return from the break. Hakuma Natata. Okay, so what kind of queries can you have? What kind of patterns you can have in queries? Query patterns. I'll tell you three patterns which are most common, but you can have other patterns as well. You're not feeling cold here in? No, it's in. I'm right now in Hyderabad. Hyderabad is not that cold. Actually, I'm feeling a little. At night, I had to turn on the fan. Hyderabad is a little hot. You are in Himachal Pradesh. Yeah, it must be really cold there. So are you? No, I'm not Telugu Yusuf. I'm from Madhya Pradesh. Yes. Okay. Yeah. Delhi is the place which gets hot also and cold also. Very. I mean, the weather is same in Lucknow. Lucknow is also like that. I used to be in Kanpur way back in my college, and it was very cold. Like, and then there were 8 a.m. classes in the campus, so I have to wake up at like 7 a.m. And I don't know why I would attend the 8 a.m. class on a cold day, but anyways, those were the days. I was Ankit, Ankit, can you focus on our our class now? I have not seen Avatar. I have typically noticed this pattern. Every Saturday students want to talk about everything other than studies. They want to talk about movies. They want to talk about what are you doing in the weekend. They want to talk about everything. But yeah, I'll tell you a story. So once I was taking a class. Which holiday is today? I don't know. Is there a? I don't know. It's Saturday. Okay. I thought there is something called as Christmas or something. There is someone. Oh, okay. So now I was taking a class, and that class was on 14th Feb, and I was taking a class, and everyone was attending the class, and I suddenly cracked like, "What are you doing in the class?" And the class has like 250 strength, and I said, "What are you doing on 14th Feb attending a class on data structures? Don't you have something else to do?" And that comment actually backfired on me because student asked, "Anshul, what you are doing here? Don't you have something to do?" And yes, and then I started making comments on 14th Feb. Anyways, there was a class on 14th Feb last year. Okay, so query patterns. There are three query. Yeah, my bosses are not that generous. When you go into teaching field, you'll not get. I'll have typically a class on 25th of December as well. So yeah, that's just part of life as a teacher. Anyways, so we have equality query. Equality query is very simple. You can have user ideas. Hmm. Okay, so equality query is where user ID. Suppose I say user ID should be equal to, yeah, user ID is equal to 200. Then you're looking for a user whose ID is equal to 200. But there can also be range query. Range query. In this range query, you can look for a range of values. For example, you can have db.users dot find the users whose age is greater than 18 and less than 23. So this will return you all the users whose age is between 18 and 23. So this is called as range query. You understand what range query is? You understand this $GT and $LT, less than and greater than? Vivek, are you following? Vivek, are you in the class? I think you are in the class. I saw your message. Gauri says yes. Ravinder? Yeah, we need the dollar here. This says this is the operator. Dollar says that GT is an operator. It's like a filter. Yeah, exactly like a filter. Okay. Query equality, sir. Equality is basically this one. A DB users. LT is less than. LT is less than. DB users dot find. You can have age as 19. This is one way, which is I'm only going to return the users with age as 19. Here I'm going to return between 18 and 23. And the last option is multi-value query with sorted result. We can also have these results sorted in order. Suppose this query returns the same query, After this query, what I do is I sort, and I sort it based on the age. So if I do this, this is the same idea. I'm returning multiple values, but now the values are sorted. So I get all the ages from 18 to 23, and the students are sorted. The users are sorted based on their age. So equality, range, and sorted results. These are the three general patterns you will see in most of the queries that you will write. Why age 1? Because I want it to be sorted in ascending order. Whenever I say 1, it means I'm talking about ascending order, increasing order. And age -1 is actually decreasing order. Age 0 is nothing current. Either it is age 1 or age -1. Okay? -1 means decreasing order, 1 means increasing order. Simple. Very simple stuff. Now I'm going to write some notes in the uh, VS Code because I think there is a student who needs the notes, so I'm going to write it for him. So this is how you can create a collection. And now to create an index, To create an index, all you need to do is db.users.create index, and then you can decide on what you want to create index. Typically, you can do it on user ID, and user ID 1 is what you're doing. And to search for, this will create an index for user ID. Okay. There is also one more thing that you need to do: explain function. This function, when you append dot explain, what do I have to say? Execution stats, I guess. There's something called as explain. Yeah. Execution status. When I do this, when I append this at the end of a query, I can get the runtime details of the query. That's explain function. And then there were three query patterns. There are three query patterns. First is which is called as equality query. I'm going to equality query. This is example of this will be db.users.find, and we can have user ID as 250. But this is one. Here we search for exact values. Then we have range query. This is also similar. This is db.users.find. Here you can do age, and then you can do dollar greater than 18, dollar less than 23, and this actually here we search for values in a range, and then we have finally sort multiple values. Query with sort results. The same query can come, and at the end of the same query, we can have sort based on, say, I can sort it based on age, or if I want, I can also sort it based on any other index that I'm looking at. So I can do something like sort based on age, and then I can do here we sort the result in. When to put braces? Whenever you are sending an object, you have to put braces. Whenever you are calling a function, you have to put a when curly braces will come when you have to put a when you have to send an object, and when you have to call a function, it's brackets. Okay. The result in SAS. Okay. So that's query pattern. You can also have compound indexes if you want. So sometimes you need to find values based on two things, not just one. Sometimes you need to find what is so just give me 1 second. Let me save this. And sometimes not only are you looking for the age, but you are also looking for number of posts. So you have users.find age. Age should be dollar greater than 18. Age should be greater than 18, and number of posts should be greater than dollar greater than 100. Okay, so this can be a function. This can be a find function. Now this will actually require you to sort it based on age, and wherever you have sorted based on age, you also want to remember inside a given age what are the number of posts that you are saving. Okay, so if posts are not, if you don't have a uh, if you don't have a combined compound index, then this might be a problem, because although you will get all the people with age 18, suddenly you again have to search for each of them inside that bucket to get all the people with number of posts greater than 100. Okay, suppose this is the list of people with all of the people with age greater than 18. You again have to search for people whose number of posts is greater than 100. So this will, although you have an index for age, if you don't have an index combining age and number of posts, it will take some more time. Does that make sense? Sorting and complexity here. A sorting will take you the same time complexity and log n. Whatever you have learned in data structures will come in handy here. Whatever you have learned there will come in handy. Now you can decide while you're creating the compound index that whether you want the index to be, uh, um, you can decide the direction of the index. So you can decide that the age should be stored in increasing order. So let me write this index. But advantage of indexing is sorting. Yeah, indexing is sorting, but advantage of is sorting. Though it will sort once, the sorting will happen once. While you are creating the index, this will happen. And then you don't have to sort again. Once you have sorted it, you can get it in login time. Query will take login time. Query will take login time. Creation will take n login time. Okay. This is what I was telling you. Got it. Okay. Now, based on your query pattern, you can decide what kind of index you want to create. Whether you want the age to be in increasing order in the index or in decreasing order. For age being increasing or decreasing, you can decide whether number of posts are increasing or decreasing. You can have increasing number of posts, decreasing number of posts. For decreasing number of age, decreasing age, you can have increasing and decreasing. All four combinations are possible. Okay. Didn't get it, Aradhya. Okay, so I'll explain this. Just don't worry about it. I'll explain it. Let me go back to my code. Let me define how to create a compound index first. Okay, you got the reason why we are creating a compound index, Aradhya Gupta? Did you get that? Yes. Okay, now I'm going to tell you how to create a compound index. Compound index. To create compound index, following command. The following command is db dot users dot collection. db dot users dot create index. And in this, instead of just sending a single value, you can send two things: age, and the value is 1, and count of posts. Count of posts as 1. Okay. Create index is 1 and count of posts is 1. This is going to increase. This is going to create an index where age is stored in sorted order and count of index is also stored in sorted order, in increasing order. It means one means increasing. Yes. So I'll write it here. One is equal to ascending and minus one is equal to descending. Okay. Aradhya, are you? Count post means you remember this this user I have created with count of, I mean it is number of posts actually, not count. So I created this user with different fields. For that user, I'm creating this number of posts and age. So there are two fields in every user. One is number of posts and the other is age. And for these two values, I'm creating an index. Does that make sense, Vivek? Vivek, does that make sense? Post Posts are basically Twitter post. When you create a post on Twitter, it is called as post. When you write something on Twitter, like you post on LinkedIn or you post on somewhere else, this is a field inside the user object or user document. Okay, and then there will be different types of uh, there can be different types of queries which will have different scenarios. If you are looking for greater than query, then one is okay. If you are looking for less than query, I mean you are looking for a query which looks something like this: db.find db.user.find, and what you're looking for is age should be dollar greater than $greater than 19, and number of posts should be dollar greater than say 100. Then this one will work well. But if you're looking for say less than 100, then then it's better to have minus one as number of posts. Okay, so that's the idea behind it. I mean, it will not cause a lot of problem, but people typically save last few milliseconds by doing this greater than less than thing. So you can check for a given query which is running faster, and then you can create your index based on that. Okay. So that is called as collections as post. For how sorting the index ascending matter, uh, how does it matter? Hmm, how does it better? No, let me think about it. Why it would be better? I mean, there will be some constant time difference between the two. I'm not sure it will be very. I mean, it will be too good, but it will be constant time update that will happen. Okay, so let me think about why it will be better. Uh, oh yeah, here is why it will be better. Let me tell you. No, let me tell you why it will be better. If I do dot sort on uh, age as minus one and number of number of posts as minus one, then if I do sorting in this order, then of course it will have to reverse all the sorted order. Okay, because my original sorting is in ascending order, but now I'm asking for a descending order. But if I want number of posts in ascending and age in descending, then of course you'll have to reverse the whole array to get the solution, and that is going to take a lot of time. Does that make sense, Likit? It depends on the sort function that you write afterwards. This greater than less than will not have any impact on it. Okay. Like we want latest entries ascending. No, this sort function is going to cause the error. Okay, so that is compound index. Vivek, did you get the last point? Ravinder? Gauri, Gauri, you seem to be quiet. Sort is a function that you can call on top of find, and it is going to return the values in sorted order. Okay, Vivek. So you can call a sort on top of a find function, and this will sort the values in. Now, if I write like age in one, it is going to sort the values from this in ascending order of age. Does that make sense, Vivek? I can sort. Do you know what sort is? We have discussed this in. Yes. Okay. That's what we are doing here. Yeah. So that's the direction that you have to choose. Now let's go to multi-key index. Multi-key index. Sometimes you also have. Sometimes you just don't have. Um, sometimes you just don't have a single value stored at a given field. Sometimes you have an array or a string. This is called as multi-key indexes. Sometimes you have arrays or strings. And then what you want to do is you need to sort those values based on you want to fetch values based on running some operations on the array or the string. Okay. So the only thing that you need to do is okay. The only thing that you have to do is if there is an array or a string, all you need to do is the code remains the same. So I'll create a hashtag. Suppose you save a hashtag for a given uh, for a given field. So what you can have is a user which looks something like this. Uh, User can have a username, user ID. Let's say the user ID is 1, and I'll just copy this from here. I'll just copy the first two, or maybe I'll copy. Oh, okay, no. A user can look like this. User ID as 1, user name, username as Anshul, Anshul, and there can be a tweet by the user. Okay, and the tweet can be I like coding in JS, like this, and then there can be some hashtags where the hashtag would be coding. This is an array, coding JS, maybe web dev, and so on and so forth. Now what I can do is I can create uh, I can create I can create an index on hashtags also, and the process is very simple. You can just do uh, db.user dot this is a particular user, so db.users dot create index, and then I can send hashtags as 1. If you do this, you'll create an index which is based on an array. Very intuitive, very simple. Now you can search for a place where hashtag is war. Okay, so or maybe you can search for something like this. Now if you do this, uh, this will create a hashtag. This will create an index for uh, hashtags. And now what you can do is db.users Where is index stored? In the database. So just like index is stored, just like the database is stored in a folder, the index will be stored in a folder. Hashtag one means it is in the increasing order of sorting. Same collection, yes, same collection. It is stored. Our index is only for a particular collection. So you create an index on a single collection. You cannot access from multiple collections. Okay. So user db.users.find, and now inside find I can do something like this. I can do hashtag. Yeah, it takes a minute. Uh, so users db.users.find hashtag, and we can say that hashtag is what I'm looking for, a JS hashtag. Okay. Now all the people all the users who have hashtag as JS will be returned. I mean, who have a single value JS in their list of values will be returned here. Okay. So this is how you can create a multi-value index in uh, multi-value index in MongoDB. Does this make sense? MongoDB multi-value index. There can also be a text index, which is also very simple. If you ask me, it's very simple. All you need to do is uh, to create a text index. Let me see if there is something else in the class. I think this is good. How multi key, not multi value, sorry, multi key. There are multiple keys for a given index because this is an array. This hashtags is an array that you are looking at. Okay, Karan? Since you are looking at array of values, it is multi key. Yeah. Now, there is one last thing that I want to talk about, which is called as text index. Now, there can be, yeah, but index was only JS, only for JS. No, index is for all the hashtags. You are searching for JS. You will have an index for coding. The coding will be linked to this. Web dev will be linked to this. And then what you can do is you can access either one of these values. So that's how you can have a multi-key index. Sorry for the break. Uh, the last type of index that you can have is a text index. What you can have is you can have the whole tweet. For example, here if you look, I like coding in JS is a tweet that you have, and you can create an index on top of this also. This will be a little different from the other indexes that you have created as far as the implementation is concerned. But what you do is you can do db.user.create index, and inside this you can send that the tweet is what I want to create an index on, and the tweet should be text. This should be text. Now a text index will be created, and then you can do bunch of things on the text index. What you can do is you can search for things inside this. So this will create a text index. This will create our text index, and you can search. You can do text search in these indexes. So what you can do is very simply db.users.find, and then we can say I think there is something wrong with this. Just give me 1 second. Okay. So what you can do is you can do tweet, tweet, and then you can do colon, dollar text, and then you can do dollar search. Yeah, exactly, Abhijit. They will auto update. As soon as you insert a new query, a new update entry, and the older index will auto update. Yeah, you don't have to worry about that. And then you can do search, and you can search for JS. Yes. Does the MongoDB uses regex kind of thing if we use text as index? Not regex, but it does something similar. I'm not sure what it does at the backend. Uh, uh, but I'm just give me 1 second. Let me see what it can do to implement this. Um, New entries will be get an index created by itself without running create. Yes, that is true, Abhijit. New entries will get an index created by themselves. You don't have to create an index yourself. Index will update automatically. So index is basically a table, and whenever you enter anything, so this is one thing that you want to remember. I'll come back to your doubt, Vishal. I don't know how it exactly works. It probably works using some string searching algorithm, but I'm not sure how it works. Maybe it works using some kind of hashing on top of text. So some text-based hashing might be used at the backend. I'm not sure. Now, Avijit, your point. You are raising a very important point, and I want to append. Since you have raised this point, I want to take some time talking about it. So, so we are talking about indexes, and this happens a lot. Whenever you have a new index and you update a value or add a value, the index gets updated. Index gets updated. And what is the unwanted side effect of this? If the index is, if you have 10 indexes, all of them are getting updated. What is the side effect of this process? Avijit, can you tell me? Time, exactly. If you have 10 indexes, all of them will be updated. So the right query takes lot uh, longer time. Insertion and update, yeah, longer time. Yeah, the right query will takes longer time if you have too many indexes. If you have too many indexes, yes, that is true. Also, deletion will take. That is true, Arnav. Very good, Arnav, that you are following. Too many indexes. No, no. If I'm adding new document, then how is the index get created? Index does not get created; it gets updated. Abhijit, there will be a list of values in the index. Okay, this is a ledger of key value pairs. Suddenly, a new key and a value comes up. Suddenly, a new documents get added, and then in that document there's a user ID, a user with a user ID of 256. Then what happens is there is a new entry in your index which says user ID is actually 256. Does that make sense? Adding this value to index will increment. Yeah. It is like pushing to index. Here atomicity will also work, so other developers will also face problem using indexes. That will not happen, Avinav. Only the document will be only the document they cannot access. They can access the index overall, but they cannot access that particular key for which the particular person is adding. Other than that, index is available. Okay. Otherwise, it will be very slow. If atomicity is there and you cannot add while the index is being taken by the other process, then the whole process will be very, very slow. You cannot work with that slow process. There will be no point of using DynamoDB then. Oh, sorry, MongoDB then. If every time I say, if every time I say DynamoDB instead of MongoDB, I should get $100. I will be very rich. So on whichever field we have created indexes in this collection, for every new document, will all the indexes will get created and updated. Not created, updated, only updated. Not created. Only that value gets pushed. You can think of it like pushing the value to the index. Okay? Yeah, that is true. So that actually ends the whole discussion about indexes. I don't have anything else to share right now. Uh, we have around 45 minutes left with us. What I want to do in these 45 minutes is to basically revise all of the things that we have done so far, because I think if we do a short revision of everything, all the things about MongoDB, if we revise it, it will be very good for all of you, because now you can remember. Yeah, now you can see the bigger picture. And maybe I can go back to the first lecture that I was taking, where I was talking about how how NoSQL databases are different from the SQL databases. Okay. Yeah, so let's do that. So we'll start with the first lecture. Let me see what I have. Intro to MongoDB. I have thrown this. Okay. I'll stop sharing this. I'll just write it as a revision. Okay. There are four parts to the revision. First is NoSQL, the overall idea about NoSQL. I'll call it one. What we have discussed in NoSQL databases is suddenly we don't have the same requirement for a relational schema as we have for NoSQL databases. So NoSQL databases, we talk about different kinds of databases, document based or key value, or we talked about column wide, or there can be graph based. All of these are different kinds of NoSQL databases. We typically looked at document databases, and we looked at one document database, which is the most famous, which is MongoDB. In MongoDB, we went ahead and we discussed further things, but let's look at the key ideas behind NoSQL. The key idea is we don't want to do too many joins in, because if join is there, then you cannot have horizontal scaling. Okay, if join is happening, then you can forget about horizontal scaling. And if there is no horizontal scaling, you cannot build a very large application. Does that make sense? If horizontal scaling is not there, then you cannot have a large application, which means very large. I mean, very large application. Typical applications it will still work, but if you have internet level application like Amazon or Microsoft, or if you have Facebook or Twitter or something like that, it would be how join or relation have relation. So basically, the idea behind horizontal scaling is you can have a same table across multiple machines. There can be multiple machines which store a single table. Now, what will happen is if you try to join a table which is stored across multiple machines with another table which is stored across multiple machines, uh, you will have problems, because you'll have to run this query across for every row in this table. You have to go across all the rows in the other table, which is across multiple machines. And suddenly there are a lot of network calls that you have to do. And every network call is costing you a lot of money. So therefore, joins are very, very costly. So we don't want joins. And to avoid joins, we have big documents which save data for us. and that is where MongoDB comes in. We can have we can have bigger documents which contains all the data that we need from our database. We also discussed about column wide, graph based, all of those databases. Once you understand what document databases are doing, others will become easy. Like when you do them, you can learn about them also. And yes, and then so once the idea of NoSQL was clear, that we are fighting against joins, the requirement came to understand. The second thing that we learned was uh, intro to MongoDB. And as I've already said, MongoDB is basically a doc type, document based database. What it means is that everything, then how it fetches how it fetches what is it? Uh, but MongoDB can have across multiple machines. Every document it will know which machine a particular document will be. SQL we have already discussed before. SQL will yeah, we will know which document is on which machine. We'll directly call that machine and get our document. It is as fast as that. There will be only one call that will happen, and that document will contain all the data that we're looking. Vivek, I didn't get your question. No, no means SQL is no SQL. No means SQL is document based. No, SQL is relational based. It has tables that we store. Okay, it's a relational database. MySQL is a relational database. Okay, so intro to MongoDB. Now MongoDB is a document-based document-based database. That's a mouthful. Document-based database. Huh. Anyways, we discussed bunch of commands, and I'll go back to the command palette now. So I'll share the screen, and I'll discuss all the commands that we have discussed for MongoDB. So intro to MongoDB commands. I don't like this. Let me close this. Let me make it better. So I'll just come here and push this forward. Then I'll come here and push this forward. I'm going to zoom. Don't worry. I know Vivek, you are on your laptop. So I'm going to zoom. No, this will not go. Address ID is this. Coordinates OID is this. This is good. Okay, everything looks fine to me now. So you see what zoom, sir. I'm going to zoom it. Let me see how much I can zoom. Yeah, I hope now you can see it. It's okay. Yeah. Okay. So this is geology. So let's just start from the starting. We started with that database operation, collection operations. This is commands on MongoDB. Okay. So we talked about bunch of we first started with the fact that MongoDB saves data in JSON and BSON. Instead of JSON, we saved in BSON. And the idea behind BSON is it has some it has some extra properties that are not there with JSON. And so to save those things, we use BSON. And we discussed how it can save you space if you have BSON. Then we went ahead and we talked about how to create a database, how to delete a database. To create, you can use DB name. To delete, you can just do db.drop database. And to go into database, you can do you can do show DBS for seeing all the databases that you have. And once you do use database name, what will happen is you will enter into that database and you will start using that particular database. Okay. Then we started talking about creating collections. Collections are nothing, but I'll go back to my slide for a few seconds. Um, so in Dynamo, so if this is SQL and this is MongoDB, um, you can have something like this. In SQL, there is DB, database on the top. Inside database, there are tables. Inside tables, there are rows. And on each row, there is a column. There are columns inside rows. In MongoDB, something similar happens. On top, there are databases. Inside database, there will be collection. Inside collection, there will be something called as document. Inside document, there will be something called as field. Okay. This is how MongoDB is there. Now we are going to discuss we'll discuss all the operations in that manner only. First, we started discussing the operations on the DB. So we have create DB and we have operation to create a DB and to drop the DB. Then we have showing the DB. Then we have collections. Collections also have three operations. One is creating collection. Another is to create a collection. What you can do is you can directly insert into the collection. If the collection is not present, it is automatically created. It does not throw an error saying there is no collection with, there is no collection with the given name. Yeah, this is one. And so collections is the same. You can look at all the list of collections. You can drop a collection by calling my collection.drop. You can insert many documents. Now let's talk about CRUD operations on documents. You can insert many documents by calling insert many. If you want to insert one document, you can call insert one. And you can find document by passing a filter and bunch of options. I have not gone into the exact details of options. I've discussed few of them, like collation I've discussed, but you can read about them. They're not that important. Sometimes they're useful, but it's not. I mean, you can just go into those details later. You can delete all the documents depending on a filter. You can update a bunch of documents by calling filter update and options. Update menu will update all those documents. We have discussed bunch of operations that you can have, like sat in and how to delete collection. To delete a collection, you can just do drop collection. There's something called as db.mycollection.drop. This will delete the collection. Okay, so I'll just save this. This will delete. Remove is also there, but remove is basically uh, I think that remove is remove is what is called obsolete or deprecated now. Drop is what you use. Remove is deprecated, so you can directly use drop. It is old. So whenever a use case is old, they remove it from the. Uh, this will delete the collection. Okay, so let's go down. Did I mess up the format? Let me see. You can delete things, and then we talked about how a particular document look like. For example, this is how a GeoJSON file look like. GeoJSON is this idea, this one. This address thing is a GeoJSON field. It contains a type and coordinates. We discussed bunch of types like point, triangle, and polygon. Something like this we can do. And then we can, once we create an index on the GeoJSON, we can search for a particular GeoJSON index. So those were a bunch of operations that you can do on DynamoDB. In last class, which happened yesterday, let me see if anything else is remaining in this part. Yeah, I also discussed about object ID. There is a function called as object ID function. So I'll show it to you, show it running to you. So I can run this function to get an object ID for a given number. So if I do let me new object ID is equal to project ID, sorry, new object ID. I can create an object ID. And now if I do new object ID, it will give me the object ID. This is the new object ID that got created. Now I can do something like this. I can look at the timestamp of this. I get timestamp. If I do this, I'll get the exact time when I created this, which is today's time, around 1 minute back. Okay, 17th of December 2022. That object will be empty. No, that object will not be empty. That will create a random object ID. Whenever I do this, it will create a random object. The key for that object is this, and it will be a long object which will be encrypted, so you don't know what that object is. Okay, but the first part is the time zone. Then second part is something else. There are three parts to the object ID. First is the value, the second is the timestamp, and there is something else is there. A random bit is also there. Okay, does that make sense, Likhit? That object will not be empty, it will be an object ID kind of object. Where do these objects get stored? Inside that field. Whenever you do that ID field, for example, let me do user DB, let me do use test, let me go to test, and then I do DB dot user dot find. If I do this, I see this. You see this ID as object ID. This is where the ID gets saved, Vijit. Okay. Every object will have a unique ID which will have a number attached to it, and this ID will save that now. This ID key will have the value saved as the object ID. Does that make sense, Abhijit? The new object created. Yes. Every time you create a new, every time you insert a new row or a new object, or sorry, a new document, a fresh ID is created. This is what that ID is. Okay, Abhijit. If not insert, then it will not get created. It will be just saved in a variable, and whenever you restart, it will go away. MongoDB created and updated it by default. Yes, MongoDB creates this and updates it by default. If you don't say ID, time lapse again. Time lapse is nothing but time and get timestamp. So once you create an ID, you can get the timestamp for that ID. And ID contains three parts. One is the timestamp. Second is the key. I mean, there's a key that you pass, and the third is the random integer that you're looking at. So every ID has three parts. Yeah. So that's how you can work with IDs. Let me go back to this. And rest everything I have covered. Projection is something, once you search something, you can decide how much of it you want to show. Just like in select, you can in SQL you can decide how much of the table you want to see. In MongoDB as well, there is something called as projection that is going to tell you how much of the data you want to see. I'll just write it here. Projection determines the amount, the fields that you want to see in the result. Okay. That's good. Now that's how you can do that's the second lecture. In which part SQL is better than NoSQL? When you want when you have a banking system, or when you want security and asset properties. Projection is something we discussed in the second class, Vivek. What you can do is, once you do the find operation, you can decide how much of it you want to project. Just like in SQL, you can do select. In SQL, you can do select star from user. This is a query. But this is one query where you are getting the whole user table. But there is also one query where you are doing select name from users. Now you are only getting the names of the users. Okay. Now similarly in MongoDB, yeah, there is something called as projection, which can uh, give you a smaller portion of the query. Okay. So let me see if I have the code for it. I think I can write the projection. Okay, I'll write the code for projection. Just give me 1 second. So suppose I'm looking on the test user, I can do db dot user dot find. I'll find all the users and I'll just do projection. And inside projection, I'll say I'm only looking for the name of the users. So I'll just do name :1. Now if I do this, I only get the name of the users and the ID. I don't get other details like address, etc. This is what projection does. Okay, Vivek, does this make sense? Yeah. So this is what a projection is. I'll show you an example. This is an example of a projection. So I'll save this. And what is 1 after name? That means I want name. If I do name as 0, then name will not be shown. So if I go back to that query, and I just do here, if I do name can't be 2, cannot be yeah. So in this game you can do underscore id. If I do this id as 0, id, no, it cannot be 2. If I do this id as 0, id will not be shown. Now only names are getting shown. Yeah, 1 and 0 have different meaning in different params. Here now you can see that only names are being shown, id is not shown. This is why I have 0 and 1. Does that make sense, Vivek? To remove and show something. Yeah. Write 2. Okay, let me write 2. Let me see what 2 is. 2 is also okay. 2 is also going to show the details. I don't know what is the value of 2. Until now, we saw 2 things. It's just Boolean. Yeah. Why only 1? I mean, this is just a Boolean. I don't know why it is. Non-zero value is true. I'm not sure why it is there, Vivek, but this is how you can see values. Either you want to show them or not want to show them. This is just a parameter that you can set on your own. Okay. How to project all except one row? You can just write it like this. If you write 0 and you don't mention anything else, all the rows except this will present. Now all the things except the ID will present. When you do one value instead of 0, then it will like this. Okay. But not get logic behind 1. So you can write true also. If you want, you can write true. Let me write true also. Let me write false. Now also it is working. So it is Boolean actually, Vivek. So instead of 1, you can write true or false. I come here and I write true. Okay. Now the values are getting shown. Yeah. So 2 gets counted as true. So those are basic implementation, low level details. You can worry about them later. Now there was an interesting question, Aradhya, is until now we saw 2 things. Are there more? There may be more things, but you can always read the documentation, Aradhya, and don't worry about them. Like when those things come, you can just read the documentation and see. They will be on the similar patterns that we are seeing right now. So you don't have to worry about it. Okay. Okay, Aradhya? Yeah. Let's go to the next. Let's go to the next lecture. In the next lecture, we talked about JSON schema. I was till lecture 2, I was always discussing about how the schema is something which is not there. It is schema less. You can do whatever you want. But in lecture 3, I discussed how there is a schema behind. You can set up the schema so that you don't have. Uh, you can set up the schema so that you don't have surprises, random surprises in your data. Something does not pops out automatically from nowhere. To deal with those surprises, we have JSON schema, and JSON schema works something like this. Uh, we discussed about two kinds of data models. One was embedded, and other was so I'll just write it here. Two types of data model. There were two types of data models. One was called as um, document structure. Sorry, one was embedded data. Embedded data. The other was called as reference data. Reference data. Okay. In embedded data, you can have something like this. You can have a user document, which is like user doc, which contains everything that you are looking for. There will be a username, say Anshul, and then there will be a contact details, which will itself be an object which contains an email, which is Anshul at gmail.com, and then there might be a phone number. Since you already have my phone number, I can write it 8185970934. I don't want to write it in a public directory. I'll write it 999955555. That is good. And then you can have access uh, access status, and then in access status you can have something like level. Access level may be 5, and he might be a dev, so type is dev. This is one way of doing it. Other way is referencing. In referencing, there will be a user document. There will be a user doc, which will only contain two things. One will be a username, is Anshul, and then there will be a user ID. What is access status? Suppose I'm talking about Aradhya. Suppose I'm talking about a system where we have developers and admins, etc. We can have access status in that case. Okay. No, DB will not crash. It will reject the entry. Joseph didn't understand reference and embedded. You will understand in just a few minutes. Joseph, can you wait for a few minutes? Just 2 minutes. Wait for it, and it will understand. You will understand it. User ID is there, and say user ID is 23. Now this is a single document. This is the user document. This will be inside. This document will be inside the user collection. Following document will be inside. No, that is not correct. Don't make that choice. Look at that is exactly opposite. When you have embedded, then you can do horizontal scaling. When you have reference, you cannot do horizontal scaling. Following document will be in user collection. Okay, then you will have two more collection. One will be the contact collection, and the contact collection which will have a contact document, contact doc. Now this contact document will contain all the information as it is than the previous document. It will have a user ID, which in this case is 23. Across this user ID I'll have an email, which is maybe anshul at gmail.com, and then there will be a phone number, which is something like 999 55555, and maybe one more 9 here. And now user document is stored. Now if you want to get the contact details of user Anshul, you'll have to get the user ID from the user doc and match that user ID with the user ID in the contact doc. Does that make sense, Nikhil? You have to match these two values across. You'll have to first find the user ID in the user doc. Okay, save it somewhere. The command is going to be aggregation. There's an aggregation command. I don't want to get into the details of aggregation, and you are not going to do this more often. Most often you will not do this, but this is another way of doing it. There's an aggregation command which can join two tables and you can work from there, Vivek. Okay. To get this contact details, I had to get the user ID from the user document and get it from the contact document. Does that make sense? The point that I wanted to make is, when you have reference types, it's difficult. You have to do joins all the time, but it is good when you want to do just uh, okay. You will not do a join. That's what I'm saying, Vivek. You are not going to do what I'm telling you to do. You are not going to get the contact details of an individual person if you are saving it in reference data. What you are going to do is, uh, you are going to get the contact details of all the users in one go. You are going to do some operations on the contact collection itself. You are not going to do collection across collection operations. Does that make sense? Yeah. So therefore I'm not telling you. Maybe in a future class, if this process continues, if you keep on asking, I'll probably show you the aggregation functions. But I think they are total waste of time for now. So, but you can do it. Just trust me on that. You can do it. So now if you are looking for all contact details of all the users, then you can directly query the contact collection. But if you want to find for one particular user, say Anshul, you want to find his contact detail as well as his access pattern, there will be an access collection also, which will contain a similar document, which will be access doc. There will be access document across for Anshul, which will have a user ID as 23, and it will have level as 5. This is the level of security that I have, level of access that I have. Reference will have something common. Yes, reference will have some user ID as common, some foreign key, some local key concept will be there. For example, user ID is a foreign key for access document, whereas it is the primary key for user document. Similar to the concept you have learned in SQL. Okay, level is there, and then type is there, which is dev. This is how you can have a reference type. And the difference between the two is, if you have reference will take too much time and to get all the details for a particular user. Now this process can speed up if you have something called as indexes. If you create indexes on all of these properly, then you can do it faster, but it will still be like 2-3 calls. At least 2 calls will happen. It'll take much longer time to get all the details for a particular user. And the other thing is, yeah, reference is more like column wide. Yeah, that is true. That is a very good distinction you have made, Vijay. Reference is similar to column wide, and the embedded will take longer time if you want to do analytics on context or access. So those are how reference type and embedded were there. Then we talked about atomicity. I said that MongoDB is atomic as long as you're talking about a single document. It is not atomic across documents. So you can update multiple documents together. And I draw a nice figure where I was talking about there can be multiple processes accessing multiple documents at a given time, and how MongoDB is going to coordinate those processes. So all those things I discussed yesterday. And then finally, I got into this business of schema. So schema is something which you can define beforehand, and anything which do not agree with the schema will not be inserted into your table. Here is what a schema for a user where a username and an email address is required is there. The username is of type string, and the minimum length is 2 and the maximum length is 50. Similarly, the email should be of this pattern that I have specified. If the pattern is not matching, it will not be matched. Okay. Uh, you can use collection modification function. You can do collection modification function to update a given collection. So all this you can do. And embedding versus referencing, we have discussed that. Should ID be defined in the schema? No, you don't need that. But you can say that you cannot say that ID should not exist in the schema. So if you say ID should not exist in the document, then the validator will not pass or something wrong will happen. ID will always be there, so you don't need as such to define it in the schema. Okay. Can you explain about atomicity again? Okay, Aradhya, I'll explain it in few minutes. Let me see if there is anything else. I also talked about type of relationships, schema validation. All this was very similar to what I am talking about right now. If there are any more questions, I'll discuss that. Otherwise, I'll take 2 minutes to discuss atomicity one more time. So here is the idea of atomicity. Suppose so you know that a computer cannot stay on a single process. There are multiple processes running together. And I typically define these processes as people, because they are serving some person. So I just might as well define them as people. And these processes have their own documents that are attached to them, their own code that is going to run. And there is a document that is there which saves the amount value. There is an amount that is saved on a document. And let's say the amount is say 100. Now there are three processes, A, B, and C. All the three processes want to update the document, update the amount in this document. First one wants to do A plus is equal to 10. The second, A amount plus is equal to 20. Third is going to do A plus is equal to 30. So these three processes are running. Now, in MongoDB, what happens is when A accesses this document, B cannot access it simultaneously and C cannot access it simultaneously. So either A, B, or C will access it one at a time. Okay. Now, what that helps is, if that is not the case, if A and B are accessing this document together, then what can happen is A might read 100 from the document and decide to update it to. So there are three steps. First is to read A plus is equal to, so A plus is equal to 10 is actually A is equal to A plus 10. So there are three processes. First read A, this is read, then combine A with 100, which is update, and then write it back to A, which is the write process. There are three processes. So read, update, and write. So read will read 100, but simultaneously B also read amount. If both of them have access, so both of them have read 100, and then what happens? A updates it to 110 and writes it back into the document. So this amount becomes 110. But then B comes up and B updates the value to 120 and then writes it. While B is writing, it can write 120 into the amount. So I have increased my amount two times by 10 and 20, but actually it got increased by only once. So that is what it means to have atomicity. When you have atomicity, A will access the document first, The amount will be 100 in the starting. It will become 110, and then B will access it. It becomes 130, 130, and then C will access it, and it becomes 160. Clean design. It's a clean design. Okay, Abhijit, does this make sense? Okay. So uh, this is what is provided by Mongo DB. In today's, so that those are the three lectures that we took. In today's lecture, we discussed about indexes. And indexes, I started off by talking about what is an index, how it gets implemented. Then I discussed about different. I discussed about how time complexity of a large collection, which we were not able to create completely, but we create like 200,000 documents in that collection. We searched for a given value in that collection, saw that the time complexity was 272 milliseconds, and then we created an index on user ID, and suddenly the time complexity was less than a millisecond. It was almost 0 milliseconds. We did that all process by using the explain function. Once we append an explain in front of a query, I can see what all went inside that query, how much time it took, and all other details of the query can be taken from there. I also talked about three types of query patterns, which are equality, range query, and multiple query with sorted results. That index post and allowed. I Yeah, that is allowed. Where Yeah, post -1 means it's in descending order. Index 1 means it's in ascending order. Okay, that is allowed in sorted sequences. That is allowed. I've I've seen that. So there are three types of sequences. Avijit, does that answer your question? I'm not sure if I've answered your question. And how it happens, you explain. Actually, actually, the thing is, the values will be stored in a B tree, so they will be in a sorted order. Once you fetch them, they will come in the sorted order in which they are stored. But if you reverse that order, if you want to get a reverse of what is stored in the index, then it will take a longer time. It will take O of n time to reverse the whole thing. That's what I was discussing when I was discussing indexes for a given sorted query. Yeah, this is what it will take. Yeah, one is ascending, -1 is descending when you create an index, and that's how the indexes are created. When you sort a particular index, it matters how you are going to sort. And compound indexes are the ones where you have multiple fields which are combining together to get you the index. Okay, to get a particular index, you are combining multiple fields. Sometimes not this field, sometimes a single field might have multiple values. For example, a field might be an array or a string, in which case it's not just a single hashable thing that you're talking about. You're not just talking about a string. You're not just talking about a number or a boolean or something like that. Now you're talking about much larger structures where you have an array or a string. In which case, what you will have is you will have a bigger index, and that index can search inside the array and look at each individual hashtags or each individual element of the array, and you can search on those individual elements by doing the same search that we have been talking about. For example, here I have created a uh, hashtag array, and I can search for a particular hashtag, and this will return me all the users with a particular hashtag included in them. Finally, I talked about text indexes and how in a single text index you can have multiple types of text patterns that you can search. You can search for a pattern, you can search for a given regex also if you want. Okay, so all those patterns you can search inside a text, and all that is supported by using a text based index. So when you do tweet colon text, you're creating a text based index inside user collection. So that is overall what I wanted to discuss inside MongoDB. Now we are going to shift our gears and we'll start coding with Mongoose. Let me write it as completed MongoDB intro, MongoDB classes, and let me push these changes. Yeah. So no, that's not required. You don't need to zoom it. I was just pushing the changes. Okay. So you don't need that zoom value. That was just GitHub. GitHub was GitHub desktop. Okay, let me stop sharing this. You see. Any questions about MongoDB that you want an answer on? We have 2 more minutes before I end the class. Just the text part is not getting. That don't worry about it. You can directly use it without understanding it completely. Basically, whenever you want to text search something, create a text-based index. I also don't know how it works in the backend, so I cannot help you there. So from next class, we'll start coding the CRML. We'll definitely start coding from next to next class. Next class, we are going to talk about Mongoose. We'll do little bit of coding, but not much. We are going to talk about Mongoose and how to design the data. But next to next class, next 4 or 5 classes, or maybe 6 classes, we are only going to discuss how to create the CRM app, nothing else. Okay. Yeah. Thank you. Thank you, Karan. So have a nice weekend. I'll drop this call after 1 minute. We have 1 more minute left uh, in, in 1 o'clock. So you too. Do you have any feedback for me? Like if anything you want to, I don't generally get the feedback. I just get one feedback usually, like whether it is going good or bad. And that also happens like once 2 3 months that I come to know about it. But if there is any feedback you have for me, you can give it here. I'll be more than happy to accommodate it into the whole lecture. Or you can just message me on WhatsApp. I don't mind. So that's also completely fine. Yeah. So that's just how I teach. Thank you. Yeah, notes are especially for current. So there is something he has a condition, so he cannot write the notes right now. So notes are only, I mean, notes are specifically, it's for everyone, but it is specifically for current, so that he don't have to write them. Okay, students, that's it for yeah, that's it for today. I hope you've enjoyed the class. Bye everyone. Bye bye. Have a good day.